Hey everyone, so we're going to go on to the next unit, which is all about complex numbers. Um, and this lesson's all about kind of simplifying numbers into these complex setups. Now, that leads into us talking about two different types of numbers, real and imaginary numbers. Now, every time we've been dealing with numbers so far, they've all been real. Basically, this means that if we take the square root of a number, typically positive number, we end up getting a real number. That's pretty much it. So any number that you could think of um, that you put into the calculator is a real number. It could be a whole number, it could be a decimal number, it could be a fractional number, it could be irrational, like a number that goes on forever, like pi. But those are all real numbers. So good examples of this are square root of 4 and square root of 5. Both of those give real numbers as answers. For square root of 4, it's plus or minus 2. For square root of 5, it's plus or minus 2.24, and so on and so on. Imaginary numbers are basically when we take the square root of a negative number. So if you actually try to use the calculator and you turn these numbers into -4 or -5, you find that the calculator will spit out an error number. So in order to actually deal with these imaginary numbers, these numbers that are square roots of negatives, what we do is we define the term square root of -1 as being equal to I. What this is going to do is it's going to turn our square root number, simplify it into a real number, or a real part, and then the imaginary part being the I. So here we do square root of -4. We get rid of the negative by putting an I outside of the square root, and now we have square root of 4. So we know what the square root of 4 is, that's plus or minus 2. So the square root of -4 can be rewritten as plus or minus 2i, where the I is this negative under the radical. This is an imaginary number because it has a number with an I attached to it. And then same thing for the square root of -5. We do the same thing. We pull out the negative by putting an I in front of the radical. And then we get plus or minus 2.24i. Yeah, that's the same thing I said before. Now, there are certain identities that you need to know with I. Basically, what happens when we raise this I term, an imaginary number, to various powers. So these are things that you just want to be able to remember. I to the 0 is 1 because, as we talked about before, any number to the 0 power is 1. If we raise I to the 1 power, we get I because, again, that's the same thing for everything. Anything raised to the first power is itself. Then we get to here. So I squared is equal to -1. This makes sense when we remember that I is just radical -1. So taking the square of this basically gets rid of the square root, and that's where that -1 comes from. And then I to the radical 3, or sorry, to the third exponent is equal to -I. So this is actually supposed to be written like that. I don't know why it's capital. All right. So these are things that you want to be able to remember. Now, what you're going to do though is anytime you see something raised to an even higher power, so let's say it was raised to the power of 13, right? So you have I to the 13, and you're trying to figure out what this is going to be. Your calculators actually don't do things with I, or at least I'll show later how you can get it, but in base, your calculators don't really deal with imaginary numbers. So what you can do is rewrite this by subtracting 4 until you get one of these numbers. So 13 minus 4 is going to be equal to, putting that into the calculator, is equal to 9. That's not one of these numbers, so I subtract 4 from it again. 9 minus 4 is 5. Still not one of these numbers. Subtract 4 from it one last time, and I get 1. So I to the first, as we saw here, is I. So that tells me that I to the 13 is equal to I. So that's what you could do whenever you have something raised to something above 3. But I'll show you how you can do really, really big numbers later on. So we get to this question, trying to evaluate these. So pause video, work itself, and we'll go over in a second. All right, so using that trick of subtracting the subtracting 4 from each of the exponents. In this first case for part A, we get I to the 4th. Well, 4 minus 4 is 0. So if I look back at that table, I to the 0 is just 1. Do the same thing for I to the 5th. 5 minus 4 is 1. So that's going to give me I. I to the 6th. 6 minus 4 is 2. That gets me negative 1. And 7 minus 4 is 3, which gets me negative I. Alright, so that's pretty much it. And it repeats this cycle over and over, which is why we could just subtract 4 from the exponents to get the numbers. Alright, so work on these questions. Pause the video and work itself. We'll go over in a second. Alright, so the square root of negative 64. Well, 64 is a perfect square. If we do square root of 64, we end up getting 8. So to get rid of that negative underneath the radical, we get an I, so we get 8I. I kind of forgot to put the plus or minus here, but just note that all these numbers have a plus or minus in front. All right, for the next one, we do something similar. 128 isn't a perfect square. It's actually can be broken up into 2 times 64. Once again, we take the negative out of the exponent, out of the square root by putting an I. And then x to the cubed is not a perfect square, so we separate it as x squared times x. 64 and x squared are perfect squares. That's 8x when we take the square root of it. So I end up getting 8ix, and then underneath the radical is still going to be a 2x. All right, so this is my imaginary number. Here's the next step. Pause the video, work itself, and we'll go over in a second. All right, so for this, we do the same thing we did before. We're going to take the 45, since it's not a perfect square, separate it into 5 times 9. The x to the 5th gets separated as x to the 4th times x. And like always, the negative comes out as an I. This is a perfect square. This is equal to 3x squared when we take the square root. So we times it by what we have in front. And we get minus 9ix squared square root of 5x. Because 3x squared times 3I is 9ix squared. And then for this one, 81 is a perfect square. So when I simplify this, I end up getting 9I. That gets multiplied by the 2/3 that we had before. And that gets me 6I. All right. So like I said, you actually can use a calculator for these terms so that you don't get an error anymore. Now what you have to do is first you have to go to the mode, which is near the top of the calculator. You go down to the 7th line and you select the choice A plus BI. This basically means that you're going to put your terms into complex numbers. Then you go to math, you go over to the number section, you go down to part 3 where it says I part, and then you plug in whatever your imaginary expression is, and you end up getting the number. The I term, like if you actually want to put in an I, usually it's near the 0, near the bottom. Obviously, all calculators are a little bit different, so you have to be a little careful with that. The only issue with this is that when you're doing numbers that aren't in complex form, this will automatically put every number into a complex form, which can mess up any other calculations later on. So sometimes it's really good to learn how to do shorthand. All right. So here's the next set. Pause the video, work itself, and you go over a second. All right. So with number 1, again, pretty straightforward. 25 is a perfect square. Square root of 25 is 5. The negative gets me an I, so I get 5i. Easy peasy. Now, for number 2, I'm going to show, again, how you do it the long way, the by hand way. But you could have also used the calculator for this. So I to the 13th is 13 minus 4. Uh, Subtract 4, I get 9. 9 minus 4 gets me 5. 5 minus 4 gets me 1. So pretty much this can be rewritten as 5i to the first, which means that my answer is 5i. Now there actually is a shorter way that you could do this. Instead of subtracting the numbers by 4, what you can do is divide the 13 by 4. When you do that, you end up getting 3.25. I don't really actually care about this number. I care about the 0.25. 0.25 is actually 1/4. This number is the same as the number in the simplest form. That's the remainder when you do long division. So you could also do it this way. Again, if you don't want to be setting your calculator to these crazy modes, you could also do this as an even shorter way of getting to this final part. All right, here's the next step. Pause the video work itself and we'll go over in a second. All right, so 51. Now, again, I'm going to show you the long way, which is why you probably wouldn't want to do it this exact way. And then I'll show the short way, but like I said, you could always use a calculator. You just keep subtracting 4 from 51 until you actually get to 3, I to the third. This is the lowest that you can get. So we go back to that table. I to the third is negative I. Bada bing, bada boom. If you wanted to do it slightly shorter, if you did 51 divided by 4, you end up getting 12.75. If I just ignore the 12.75 is 3 divided by 4. So that's where that 3 comes from. For this next line, I to the 4th, I to the 12th, I to the 16th, I to the 36th. Do the same thing. We keep subtracting 4 from it. It actually turns out that as we continue doing this, every single one of these terms will end up going down to I to the 0. So this becomes I to the 0, this is I to the 0, I to the 0, I to 0, which as we know is just 1. So what we end up doing is combining the coefficients. So what I'm doing is this becomes 1 minus 6 minus 1 plus 2. And when I add all this together, I end up getting negative 4. All right. All right, so here's the next set. Pause the video work itself, and we'll go over in a second. All right, now as you can see, I to the 1237, 1237, way too big of a number for me to be doing the subtraction. So if you either put this into the calculator or, like I said, divided this by 4, what you find is that this actually just simplifies to I to the first, which we know is just I. Doing the same thing for this one. When we bring this down to their more simplified forms, I to the 26 is just I squared, I to the 6 is also I squared, I to the 5th is I to the first, and I to the 13th is I to the first. We can clean this up a little bit. I squared is going to be negative 1, so both those become negative 1. I to the first is just I, so this becomes minus 2i plus I. Combine this together, and we get negative 2 minus I. I don't have it in here, but I'll mention it now. This is actually what we call a complex number, a number that combines both a real number and an imaginary number. But that's pretty much it. We're going to finish talking about how we can do things with these complex numbers later on. If you have questions, feel free to let me know. Otherwise, see you later. Good luck and have a great day.